If you've ever worked with CAD, you know it is the absolute gold standard for precision. But what happens when you need to take one of those beautiful, super detailed models and actually use it in, say, a real-time simulation or a virtual world? Well, that's the challenge we're going to tackle right now, how to bridge that gap from perfect precision to real-time performance. So let's just start with the big question. Your models are these incredible masterpieces of design, right? They're perfect for manufacturing, but are they really ready for the demands of a digital twin, or a VR training session, or even just a collaborative design review? The short answer is probably not. Not right out of the box, anyway. And that brings us right to the heart of what we call the CAD simulation problem. It's this classic conflict where a CAD model's greatest strength, all that amazing detail, actually becomes its biggest weakness when you try to use it in real-time applications. I mean, this is the core of the issue, right here. Your CAD assets are just packed, and I mean packed, with millions and millions of polygons. And while that density is exactly what you need for manufacturing, for a poor GPU that's trying to render 60 frames per second, it is an absolute performance nightmare. So, this is the transformation we're aiming for. Over on the left, you've got your standard, heavy, dense CAD file. And on the right, that's our goal, an asset that's lightweight, optimized, and ready for any real-time engine you can throw at it. The big question is, how do we get from one to the other? Well, the key, the solution, is a framework called OpenUSD. And really the best way to think about it isn't as just another file format. It's more like a universal language for 3D data, one that's capable of describing entire virtual worlds. And let's be super clear here. OpenUSD, which stands for Universal Scene Description, is way more than just a file type. It's a whole framework. It was designed from the ground up to handle the crazy complexity of modern 3D pipelines, which, it turns out, makes it the perfect tool to solve our CAD problem. And believe me, it comes with some serious superpowers. We're talking about a non-destructive layering system, which is a total game changer for teamwork. It's extensible, which means you can basically teach it new tricks. And it's amazing at handling massive, complicated scenes without duplicating data, which keeps everything super clean and efficient. You know, here's a really fantastic way to think about this. If OpenUSD is the language, then schemas are kind of like the grammar. They're these standardized blueprints that make sure any application can understand not just the data itself, but the intent behind the data. It's a huge deal. Okay, theory is great, but let's get practical. How do you actually do this? Here's a super straightforward 4-step guide to take your CAD model and get it ready for simulation using this powerful framework. At the end of the day, the whole process really boils down to these 4 steps. First, you export from your CAD program into a format like JT. Second, you use a platform like NVIDIA's Omniverse to convert that file to USD. Third, and this is the magic step, you optimize it. And finally, you get to the fun part, applying all your high-fidelity materials. Let's just pause and focus on that optimization step. Because honestly, this is where we solve that huge performance bottleneck. It's the whole process of intelligently shrinking that heavy geometry without losing the visual quality we need. So what is the optimizer actually doing under the hood? Well, it's incredibly smart. It's merging meshes that don't need to be separate. It's hiding all the internal parts of a model that the camera's never ever going to see, which saves a ton of GPU power. It also cleans up duplicated materials and intelligently reduces the overall polygon count. And the result? It can be absolutely mind-blowing. In the example this is based on, a really complex CAD assembly was optimized all the way down to just 2.31 megabytes. Think about that. A massive, heavy-duty asset made incredibly lightweight and ready for pretty much anything. All right, so you've got the basics down. Now, let's talk about how to work like a real pro. To work smarter, not just harder, we need to lean into one of OpenUSD's most powerful core features, its non-destructive layering system. This concept is everything. Being non-destructive means you can make all the changes and optimizations you want without ever touching the original source data. It's basically like having an infinite undo button for your entire project. And this brings us to the single most important rule of this entire workflow. If you take away just one thing, let it be this. Never, ever edit your master file directly. You have to treat it as your protected, sacred source of truth. So how does that actually work in practice? It's surprisingly simple. You just create a new blank scene. Then you bring your master model in as a reference. From that point on, any change you make, whether it's running the optimizer or adding a new coat of paint, is saved as a separate layer right on top. The original file, it stays completely pristine and untouched. Okay, let's bring this all home. When you follow this process, you're not just converting a file from one format to another. You're fundamentally unlocking the potential of your engineering data for your entire organization. The real-world impact of this is just huge. Your lighting artist and your simulation engineer can work on the exact same model at the same time without stepping on each other's toes. If an engineer updates the original CAD model, those changes just flow right through the pipeline, automatically. Your data is finally free, ready for any modern application you want to use it in. So by turning that high-precision CAD into high-performance assets, you're making your data more flexible, and you're making your teams way more efficient. You're really opening up a whole universe of new possibilities. Which leaves us with just one final question. What new worlds will you simulate?